Yes, Varun, are you ready? Are you ready? Hello. Varun. Hello. Hello. Varun. Hello. Hello. Yes, Varun, what happened? Yeah, you're not responding. I'm asking so many questions, you're not responding. Are you browsing something else? No. Okay. Yeah, I know, but I was waiting for a few minutes, but though I asked questions, you are not responding. I thought that you are browsing something else. No problem. Shall we start the class now? Okay. Yeah. So earlier we have seen about the different technical terms regarding the spherical mirrors, isn't it? Today we are going to see how the images are formed, how to locate the images for various positions of the objects. That is, representation of images formed by spherical mirrors using ray diagrams. Usually diagrams, in physics there are so many diagrams. Here, when it comes to optics, it is called a ray diagram, because to represent the path of light, we take only a line, okay, the direction, that is in which way the light is traveling. It can be represented by using a straight line, that is called a ray. A ray is nothing but the path in which the light is traveling, that is called a ray. So by using this kind of rays, by drawing this schematic diagrams of the path in which the light is traveling, we can locate the images. What is the shape, what kind of image is that, whether it is virtual, whether it is inverted or erect or diminished or enlarged, all those things can be found out theoretically. Okay, practically it is possible, but theoretically you can do it by using this kind of ray diagrams. Okay, right. Now, to study this, by constructing this ray diagrams, we can study only by using any two rays. Usually, as we have already discussed, if you take a beam of light is nothing but a bunch of rays. So many rays together forms the beam of light. If it, as I told you, if you shine a torchlight, the light which is coming out of the torchlight, it can be considered as a beam. The headlights of a car or bikes, which is giving out a beam of light. So that beam of light is imagined to be consisting of so many rays, a bunch of rays. Among this, if we take any two rays, right, we can easily locate we can easily construct the ray diagrams. Thereby we study the image formation, right. So here there is an example here how to draw a ray diagram. It's an example for ray diagram, right. Now, here there are so many ways. These rays are conveniently chosen that it is easy for us to locate the directions after reflection from the mirror, because the mirror will reflect the light of ray. So, in which way it is going to reflect? In such a way that we will have to choose conveniently so that it is easy for us to locate the image. And as I already told you, any two rays are sufficient enough to locate the image. And when you are taking two rays, conveniently, the intersection of these two rays after reflection will be sufficient enough to understand or locate the position of the image of a point object. Point object is the one which is at a distance. Okay, so when these two rays after reflection, when they intersect, we can locate easily. For example, here you can see this is one ray. Okay, this is the ray. After reflection, this is the another ray which is passing through the principal axis. So after reflection, it is coming out, so that you can easily locate where is the image formed. So it is very easy to locate the image by taking only two rays. Right. Now, among the following four kinds, we are going to choose any two of this. Okay, it is easy to understand. Suppose if we take any two rays, how will they intersect and which point they will create an image. To understand this, here it is a point, first point. Now the first point is a ray which is parallel to the principal axis. Here this is the principal axis which is passing through the pole. We know that, we have already studied what is a principal axis. A ray of light or a line, imaginary line passing through the principal axis. Now we are going to consider one ray which is parallel to the principal axis. Okay, this ray is parallel to the principal axis. Now after falling on the spherical lens, what happens? In which direction will it pass through? When it is parallel, it will pass through the principal focus. You have to remember. And it is converse of this. Yeah, through the principal focus. In case this is converse, you can see it is opposite. Suppose if the ray is passing through the principal focus, definitely what will happen? It will be parallel to the principal axis. So both are opposite each other. Okay, the cause and the effect like that we can take. Okay, so and remember that if it is concave, it will be passing through the principal focus. And if it is convex mirror, what we have to do? We have to say that it may appear to diverge from the principal focus. If it is a convex lens, okay, this is the side. So the spherical mirror will be like this, ball will be like this. So the principal focus will be behind the mirror. You have to remember. So already we have understood how the in this sphere, if you take this as the lens, that is mirror, where the reflecting surface is here, so the center of curvature here, principal focus is here. Now we are taking the convex lens where the reflecting surface is this side. So the shaded portion is the polished, that is coated surface. So the reflection is here. So that the principal focus will be behind the mirror. So that we have to understand like that. So when you are taking a convex lens, the principal focus is behind the mirror. So we have to understand that the ray which is passing through the which is passing parallel to the principal axis will appear to diverge from the principal focus of the convex mirror. Will appear to diverge. Actually, it is not so. But when you look at that mirror, convex mirror, the image may appear to diverge from that principal focus. So that is the one we have to remember. So appears to diverge from the convex, but here it is exactly it is passing through the principal focus. So these are the two differences you have to understand. So what is the ray we are taking now? Two rays we are taking. One ray is parallel to the principal axis. The other ray is passing through the principal focus after reflection. With these two rays, we are able to locate the image. Okay, right. The next one, a ray passing through the principal focus. Earlier we have said that it is parallel to the principal focus. Okay, now a ray passing through the principal focus. So what is that? After reflection, what will happen? It is the previous one, opposite. Yeah, opposite to the previous one. Now see. Now it is passing the principal focus. After reflection, it will go parallel to the principal focus. It is the converse of that. Okay. And similarly, for convex mirror, after reflection, it will emerge parallel to the principal axis. Okay. For concave mirror, it is appear. Okay, for concave mirror, the ray directed towards the principal focus of a convex mirror after reflection will emerge parallel. So the word appear is only for convex. For concave it is easy to locate because the image will be formed in front of that. Okay, it is easy for us to locate that. So that is the opposite of the previous one. Easily you can understand. The third one is a ray passing through the center of curvature. Suppose a ray is passing through the center of curvature, through this one. Okay, so what will happen? Whether it is through the center of curvature or directed towards the center of curvature, after reflection it is reflected back along the same path. It will come through the same path. It is like a rubber ball. After bumping on the wall, it is coming back like that. Okay, it is thrown back like this. When it is passing through that, again it will be reflected back through that. And here it is appear to. Here we have to add that word. When it is directed towards, here we can say it is passing through. For concave, we have to say it is passing through the center of curvature because we know the center of curvature easily because it went off the mirror. Okay, so it is passing through that, so it is directed towards that. And similarly here, it cannot say that it is only directed towards the center of curvature, will appear to reflect back in the same path. It will trace the same path. It is coming out in the same path. So this is the third one. Now the fourth one, a ray which is incident at an angle, we say obliquely. Oblique means at an angle, inclined to the principal axis. See, this is the principal axis. To the principal axis, it is inclined at an angle, at some angle, and it is towards the pole. Okay, whether it is on a concave mirror or a convex mirror, is reflected obliquely. At what angle it is falling, it is in the same angle, it is reflected back. So when it is at the point P, you can remember that this may act like a plane mirror. Okay, since it is a point, pole, if you forget everything, if you consider this point alone, it is similar to a plane mirror. In a plane mirror, what angle the ray is falling, in the same angle it will be reflecting. You can also test it. You can take a torch light, take a mirror and shine the torch light. If you shine that directly, the light will come back. If you take it at an angle, at what angle it is falling, in the same angle it will come down, isn't it? Since it is a point one, it may be considered as a plane mirror only for this ray. Okay, so whatever angle it is making, it will be making equal angles. It will follow the laws of reflection. Okay, that is the fourth one. Now, in all the four cases, what is the point we have to note down? That they are following the laws of reflection. What is the laws of reflection? At the point of incident, the incident ray is reflected in such a way that the angle of reflection is equal to the angle of incidence in all the cases. In all the cases, they will follow the laws of reflection. Okay, the laws of reflection, because it is a polished surface, plain like a mirror surface. So definitely it will obey the laws of reflections. Right. Now let us see how the images are formed by concave mirror. Like what you have seen so far is the rays. In such a way, you have to choose to locate the image, isn't it? Now we are going to see for different positions of the object how the images are formed. Okay, this is one of the important question. Based on that, you can also do practicals. As I said, you can take a small, you can buy a mirror and do the testing or experiment at home. Now let us see. The first point is, what is the position of the object? We are going to take an object which is at infinite distance. Infinite distance means it is, you cannot say that it is at some crores of kilometers away. It is assumed that at a distance, at a far away distance. Okay, like for example, you can take a image of a tree as an object. From the window, you can take the image of a tree by keeping the spherical mirror focusing towards the tree. The tree can be considered as an image object at an infinite distance. Okay, so when the object is at infinite distance, so I am just assuming that the object is here. Okay, right. Now, how to locate that? This is the image AB, for example. Okay. Now we are going to take two rays from here to here. AB is the image. Now we are taking rays. When it is at infinite distance, the rays are falling parallel, isn't it? Parallel to that. You know that when it is taking parallel, naturally what is the first point we have seen? After reflection, what will happen? They will converge at the principal focus. So the position of the image will be definitely at the principal focus. Why should I take this as parallel one? Because if you forget this, object is at infinite distance. When the light is falling on the object, after reflection from the object, the rays will be traveling parallel. In different direction it will be traveling, but when it is traveling, we are keeping a spherical mirror here. So when they are traveling, it is meeting at the point F. Okay, now how to locate the image now? After that, it is coming down and this is coming down. We are putting the point and we are getting the image downward. That is, you can say that it is inverted one. Image will be inverted one. Okay. So highly diminished and point sized. That means when the object is at infinite distance, the image will be very, very small. Very small, what you call it as diminished image, but it will be a real one, but inverted one. Okay, upside down. The image will be upside down. Suppose if you take that spherical mirror, concave mirror, focus the tree and keep a paper here, white paper or screen. Just if you focus this on the screen, you can see the exact image of the tree on the paper or screen, white paper or screen, but it will be a small one and inverted one. But it will be very clear to see. Pardon? It is not a plane mirror. It is not a plane mirror. It is a spherical mirror. I am talking about plane mirror virtual. Yes, plane mirror is virtual because by using the plane mirror you cannot get the image on the screen. Even if you take your the mirror which you are using for looking at your face, that using that you cannot catch the image on the screen. Such kind of images are called virtual. But here for this concave mirror, the image is a real one. You can get that image on the screen. You can focus it on the paper and get the image nicely. Very, very clear it will be. So this is the first one you have to understand. The second one is, here is the object. At which point we are taking the object? Beyond C. Beyond C means it is not infinite distance. It is not at infinite distance. C is the center of curvature. Okay. Before, in between C and F, if you take beyond C means you have to take away from that. That is, from the pole, after C you can take any point. That is called beyond C. Okay, it can be here or here, anywhere it can be. But after C you have to take. Okay, that is called beyond C. So this is the image. Now see that the ray is coming from here. It is falling. After falling, what will happen? It will pass through the principal focus. The other ray is taking from there and it is directed towards the center of curvature. Usually what will happen? When it is directed towards the center of curvature, it will reflect back in the same way. Isn't it? So now both of them are intersecting. When it is intersecting, this point, the point of intersection will give you the position of the image. Now you can see the size. When you compare with the size of the image, see how small it is, but it is inverted one. Since, why do we say it is inverted one? Because below the principal axis we are getting. If the object is got above the principal axis, it will be definitely erect one. But since it is below that, it is downward. So it is called a inverted one. Okay, upside down. But it is a real one. Why? Because it is a concave mirror real image. Okay, these points you can easily remember. By looking at the size, you can say the relative size of the image is diminished. By looking at that arrow mark, you can say it is inverted. And since it is a concave mirror, it is a real one. So by this way, and location we can see. By drawing this perfectly diagram, since the image is got in between C and F, say directly you can say between principal focus and the center of curvature. Right? So, what kind of rays we are taking? Easily we can locate the image. Okay? So, beyond C means it between C and F. If it is infinite, principal focus. That way, you can easily locate the position of the image. The next one is at C, at the center of curvature. Let us see at center of curvature, if the object is kept, what happens? Now this is the center of curvature, okay? If the object is got at the center of curvature, the rays are taken in such a way when it is parallel, okay? When it is parallel, so it will pass through the principal focus. You know that, isn't it? Again, from here when you take another ray which is passing through this principal focus, it is opposite to that. It will go parallel to that. When it is parallel, it is through the principal focus. When it is through the principal focus, it will be parallel. So we have taken both the rays. Now what is the intersection of these two? It is at the principal focus. So when the object is at the center of curvature, right? Now see that this is the point we have taken from here to here, right? When it is parallel, it is passing through the principal focus. When it is passing through the principal focus, it is parallel. Now, at what point these two are intersecting, this is the point. If you extend the point, you will understand, right? If you extend the point, you will understand this is the intersection point, point of intersection, isn't it? So, from here you have to draw the arrow mark. So, what is that? From this point, principal focus to this point, this is the image. Now, you can compare with these two. Both the object and image are of the same size. Yes or no? So, when it is at the center of curvature, the object is at the center of curvature, image will also be at the center of curvature. Do you understand? So, what is the size? As same as the object. What is that? Real image. Whether it is inverted or erect, it is inverted, downward. Okay? Have you understood that? What are the two rays we have taken? Can you tell me? Name that ray. What are the two rays we have taken for getting the image of this? I am not hearing. I am not able to hear. Put that properly. Pardon? Yes, tell me. No. I'm asking you to name the ray. You have to name the ray like AE or BC, AC, AD, like that. You have to name the ray. Tell me what are the two rays we have taken now. AD, AE, very good. AD, AE. Now what are the reflected ray? No. Reflected ray. No. Huh? No. You said first one, AD. Now, that AD, what is the reflected ray for AD? No. First one, you take the first ray. AD is the first ray. For that AD ray, what is the reflected ray? DA, very good. That's what. For AD, the reflected ray is DA. Similarly, for AE, what is the reflected ray? EA, that's all. Now, this DA and EA, these are the two reflected ray. When these two ray, DA and EA, where are they meeting at one point, intersecting? That point is nothing but A. We have taken it as say A dash. Instead of A, we take this as A dash. So, Usually the image is, if it is AB, we take this as A dash B dash. Usually that is the notation we take. So this point of intersection is called the A dash, and this A dash B dash is nothing but the image. So this is how we have to locate that. So at C is the position of the image, and what is the relative size? Since when you compare with that, it is same size. So same size, and since it is concave mirror, real image, and it is arrow mark is downward, so it is inverted one. So this is how we have to locate. In the exams, they will give the ray diagram. Simply they will give the ray diagram, they will give the object, and they will give the ray. Only two rays they will give, and you will be asked to find out the position, nature, and the size of the image. So we have to complete it. In the exam, they will be asking you to complete the image and locate the position of the object. Simply by looking at that, you have to remember the different 4 points I gave, in that 4 points, in which category it is falling. When it is parallel, it will pass through the principal focus. Okay, when it is passing the principal focus, it will be parallel. So where they are meeting, where they are intersecting. So I will complete this one. So this is the position. So in this way, by completing the diagram, you will be asked to find out the position of the image. Okay, that is the point. The next one is between C and F. So far we have seen about infinite distance beyond C, at C. Now between C and F. In between C and F, we are keeping the object AB. Okay. Now again, for this object, we are going to take two rays. Okay. Now what are the two rays we can take? One ray is parallel. See, when it is, suppose if it is parallel to the principal axis, it will pass through the principal focus. Any ray which is parallel to the principal focus will pass through the principal focus. When any ray parallel to the principal axis will be directed towards the principal focus. That point we know. The other ray is taken from here when it is obliquely falling on that. Okay. So what happens? At what angle it is falling? It is coming back. It is, or otherwise you can consider this as when it is taken from here, in such a way we have taken a ray which is passing through the center of curvature. So when it is center of curvature, it will come through the center of curvature. Okay. So what happens? So these two rays, they are meeting at one point. So A dash B dash, or A1 B1, this is the image. Now you can compare the image. Here it is moving upward, so it is erect. Here it is downward, so it is inverted. It is real one. So can size the comparatively, you can see that it is larger. The size of the object image is larger. Okay. So this way we can see in between C and F means the image will be beyond C. It will be beyond C. Okay, and it is enlarged one and real and inverted. Okay, these are the different positions. The next point is at F. So far we have seen between C and F. Now if it is at F, exactly what happens? Let us see. The object is at F, that is at the principal focus. Okay. Now we take the again we take the two rays. One ray is parallel to the principal axis. The other ray is in such a way we have taken as if it is coming from the center of curvature. Okay, we are just taking this curve. So what happens? Center of curvature means it will be tracing the same path. The other one is parallel, so it will pass through the principal focus. Now you can see these two rays are parallel. Do you think that they will meet at any one point? Will they intersect at any one point? No, they will never intersect. So it means that we cannot get the image at all. But we can say that at infinite distance, we may get the image. Now we can just compare with this first one. In the first point we have seen that when the rays are parallel to the principal axis, where the image was got at the principal focus. Yes or no? Now this is quite opposite to that. When the object is at the principal focus, the image will be got at the infinite distance. It is assumed that at infinite point these two rays will coincide. That is, they will intersect. Okay. So, what could be the image? Highly enlarged, because when they are going to meet at one point, suppose you can compare that. How to locate the? Suppose if they are meeting at this point, just draw that relatively with this one it is larger. Again, when they are meeting at this point, when you keep on drawing like this, the image of this, that is the size of the image will be keep on increasing. So definitely highly enlarged image will be got, but we do not know the position where it will be meeting. So that we say that at infinite position only we will be getting the image of the object when it is kept at the principal focus. Have we got it? Right. Now, this is how we have to draw the ray diagrams and find out the position of the images for different. The next one is at the principal focus we have seen. And again, is it possible to keep the object very closer? That is, in between principal focus and the pole, very nearer to the mirror. That is, in between the pole and the principal focus. Okay, this is the object here. Now, again, when I am keeping it here, the rays are taken in such a way that when it is very closer to the mirror, the image will be formed behind the mirror. It is something like, as I said in the beginning, it will be like a plane mirror. It will be like a plane mirror, because when it is very closer, you can assume that the surface is to be like a plane. Like how we are able to view the earth. When you look at the sea, for example, have you ever visited a seashore? Have you ever played a seashore? Yes? You have not visited any beach so far? Oh my God, you never miss that, because it is a very amazing thing to understand the God's creation. Now, when you just stand near the seashore and look at that, imagine the shape of the earth. The earth is spherical in nature, right? As you view the ocean, a big ocean, the water is just it be like like a football. The water will be like on a football, right? How it is. But have you ever felt that though the surface of the earth is spherical, we can never see the spherical surface anywhere. The earth is flat always, everywhere. Why the earth is flat always, everywhere? And people say that it is like a sphere, ball of sphere. Why is it so? Can you tell me? Have you ever had this kind of questions in your mind? No. Do you understand the question, first of all? Yes or no? Do you understand the question, first of all? What kind of question I'm asking? Yeah. See, for example, you take a bow, for example, or a stick which is bent like this. Okay, you are standing here. Now, when you look at that, you can say that it is a bent one. It is curved in shape. Right? Now I am going to increase the size like this. To some extent you would say that definitely sir, yes it is a curved one. And similarly, if I keep on increasing, right, in such a way that it is so big, and you are able to see only a part of this. Only a part of this. That is, it is extending on both sides like this. On both sides. When you compare to your size and this one, it is infinite distance and you are standing here. When you look at that, what you will say? You will say that it is flat. It is not curved one. You will say it is flat. Similar to that also, when you compare your size and the size of the earth or the surface, it is so large that you may assume that it is flat only, but actually it is a curved one. Isn't it? Yes or no? So that is why you should see when you go to the seashore beach and look at that, no, it will be enthralling, thrilling one. When you stand near the beach water and the waves or tides are coming at a high speed, that too in the evening around 6:30 in the light, dark, and when the sun sets, at the time if you watch that, that feeling will be very, very interesting and you will enjoy that. You will never forget that. The sound of the tides, waves, and the dark blue and a dark black color ocean and the sunset, the sky, everything, you will be wondering about the God, how He has created such a nice natural scenery like that. Okay, and also you can apply that for our scientific temperament. You can approach that with the scientific idea. And similarly, when you take a big one, right? When the mirror is bigger one like that, and you are taking an object nearby, so small, what will happen when compare with that? We are taking only small part of the mirror, so that for a plane mirror, definitely what will happen? The image will be behind that. Image will be behind that. So that what we have to take, the rays, two rays we are taking. One is passing through the center of curvature. This is the passing through the center of curvature. The other one is here. Okay. Now, when it is passing through the center of curvature, after falling that, what will happen? It may appear to start from this and passing through the pole. One is passing through the center of curvature. Where it is directed here, again it will be coming back here. Okay. The other one is appear to start from here. So when these rays, when they are meeting here, it will be meeting at this point. It may appear to start from this point. Okay. Only at this, for this concave mirror, we take this word appear to start. Usually we take this for convex, but here only for the position where between F and P, we assume that the rays are meeting behind the mirror. The rays are meeting behind the mirror, or since it is behind the mirror, we say they appear to emerge from that. So at that point, we draw a line, straight line, and that will be the position of the image. Naturally, you can see the size, it is enlarged one, and it is virtual one. It is not a real one. This is the word we are using here. So far we have seen that all the images are real, but only for this position we say the image is virtual because it is behind the mirror, which cannot be caught on the screen. Okay, so these are the different positions, 6 different positions we have seen, and how we have located the images caught for the position, different positions. Hope you have understood. Do you have any doubt in this? In all the 6 points, have you understood? And always remember when you are, when you are writing exams or when you are appearing for exams, you compare what are the two positions which are relative to each other. One is, as we already discussed, when it is parallel means it is passing the principal focus. When it is passing the principal focus, it is parallel. Like that, you take a clubbed one, like a pair. One pair is this one, another pair is this one. The last point is a virtual one. Like this, you can easily remember. Okay, so that you can easily locate the images, position of the image for every position of the object. The next one is the uses. These concave mirrors are playing a vital role in our day-to-day life. They are mostly used, here you can see, in torchlights, in searchlights, or vehicle headlights. In all these kind of lights, they are useful for getting a powerful parallel beam of light. Okay. So, yeah, are you asking any question? Yeah? Yes, Varun, did you ask any question? Yeah, okay. Okay, right. Now, apart from this, getting a beam of light, a very powerful beam of light, they are used in shaving mirrors to see the larger image of the face. Usually in the shaving mirror, generally we people are using the ordinary plain mirror only for shaving, right? But there is a special mirror available for shaving, because you have to look at the face properly for shaving. Otherwise, you will be leaving small spots where it will be ugly to look at that, isn't it? To have a clean shave, usually people use a special kind of shaving mirror, so the face will be enlarged one, becoming bigger one. When you come closer, it will look like a bigger one, so that you can cleanly shave. For that also, these kind of concave mirrors are used. And especially the dentist, they use the concave mirrors to see the large image of the teeth of the patient. You can see that here, not only for outside that, right? Inside also they can see, because when any patient is coming with a tooth decay or cavity, the dentist cannot insert his head inside the mouth of the patient and see the teeth. It is very difficult, no? So they will find it difficult. So for such occasions, they will use these kind of mirrors. They will insert inside and slightly rotate, so that it will be reflected on the mirror, concave mirror, and will be seen by the doctor very clearly. We use this for seeing. Okay. And another one is, yes, tell me. You are not able to hear? Problem with your headset, I think. Are you able to hear now? Okay, okay. Right, shall we continue? Pardon, streaming is? Sorry, what did you say? Streaming is not proper. Now is it clear now? That means your bandwidth is very slow, your internet speed is low, because it is peak hours, in the evening. Yeah, in the evening, usually it is peak hours, so it will get stuck. Speed will be, actually it is shared. Many people are sharing that broadband. Yes. At the time it will be like that only. That is why we prefer always somewhat high speed plan, so that you will not have any kind of kind of
cannot hear you.
Yeah, it is called a okay. Then we'll see you in the next class. Bye.